Hello dear friends, welcome to another video of the Never Do Through the GUI what you can do through the CLI channel. I am Vangelis Prokopiou and today you are watching why a new language, Rust in this case, instead of fixing C++. So this is a question that has been in my mind for some time and I did not have a solid answer on this, but recently through a third-party article which I will share with you, I got the answer for myself, and this is what I want to share in this video. So with no further ado, let's proceed. And it all started with this blog post from Google Security Blog. They posted this about memory safety in Chrome. And there is a lot of interesting information in here. In case you haven't read it, I suggest you do. But what pertains to our video today is related to this link that they included in this blog post, and the paragraph says reads thus. Where is it? Here it is. Ideally, we'd choose option 1, make C++ safer at compile time. Unfortunately, the language just isn't designed that way. You can learn more about the investigation we've done in this area in this article that we're also publishing today. So if we open this link and we start reading this article, there is a lot of information too in here that is interesting. Of course, I'm not a language expert in order to judge the information in here. I'm just sharing it with you. And the end result of all this, the conclusion of the article is this. Conclusion. So the Google engineers say that we attempted to represent ownership and borrowing through the C++ type system. However, the language does not lend itself to this. Thus, memory safety in C++ could need to be achieved through runtime checks. And when I read this, I was blown away literally, because in my mind I would also think that adding these compile time guarantees in C++ would also be feasible and possible. And as I said, I was myself wondering why don't they do it instead of creating a new language and spending so much effort on it. But as you see here, it seems that it is not possible for the reasons that are explained in this article. And as I said, this was a big surprise for me. So it seems that memory safety is a one-way street, and at the end of it we find Rust, the Rust language. And this is why in my mind, and I believe that Rust will expand and take the position of C++ and C, at least for new code, for new implementations, not by rewriting everything, of course, because this is a huge effort. But in the long run and in the future, I believe, and it is happening already now, new code related to critical systems is being implemented in Rust, like for example Rustls, which is a TLS implementation in Rust, and it will also be used in curl. Curl is collaborating with the Rust ecosystem in order to include the backend written in Rust. So yeah, the point is not to ramble a lot. The point is that C++ cannot be turned into a memory safe language in the sense that Rust is, and this is a huge surprise for me, as I already said. I would really like to know your thoughts on this issue too. You can comment on it in the video if you like, because I think it is a huge thing that C++ cannot be made memory safe, and our only alternative currently is Rust. Thank you for watching. This is all that I wanted to share in this video. Thank you for watching, and see you soon.